In the previous video, I demonstrated writing this LabMarks class using the test-driven development, or TDD, methodology. Using this methodology, I cycle through writing a short unit test and then writing a bit of code in my implementation class to make that test pass. Then by cycling through this, we write a sequence of tests and all of the methods that this class needs. Once I've written the class as I want it, that's not the end of the story. We often have to maintain code later, or we think of ways to improve it. So in this video, I'm going to demonstrate refactoring the LabMarks class so that it works in a different way, but still has the same outward behavior. In particular, I'm going to refactor the getTotal method so that I can split the behavior across two methods. The reason I'm doing this refactor is that this getTotal method, as I've written it, is actually doing two things. The first thing it's doing is constructing a list of all of the marks that have been set. That's this part of the code. We're building a list containing the marks that have been set. And then the second thing that it's doing is getting the total of the best 8 of those marks. And that's what this part of the code is doing. But because this method is doing two logically distinct things, I'm going to refactor this by splitting those two different actions over two different methods. And that means that I'm still going to have a getTotal method that gives me the total of the best 8 marks, but I'm also going to have a method that gives me a list of all of the marks that have been set. And I'm going to call that method getAllMarks. Because we're using the TDD methodology and I have a complete unit test class which tests all of the behaviors I've written, we can use the unit tests to be sure while I'm refactoring that my refactor is correct and doesn't change the behavior of the code. To start off with, I'm going to write a unit test for the new method, which is going to be named getAllMarks. So this test will be called testGetAllMarks. And all I'm going to do is assert that if I haven't set any marks, then this getAllMarks method is going to return an empty list. Because if there are no marks, then the marks that are set will be empty. To do this, I'm going to compare the getAllMarks method with an empty list. So I'm going to use the collections.emptyList method. And then I'm going to call marks.getAllMarks. So the empty list method here will give me my expected result. Then the actual result is what I get by calling getAllMarks. And now this code doesn't compile because I'm referring to a method named getAllMarks, which I haven't written yet. So we'll move to the implementation code and at least make the test compile. This method should return a list of doubles because it's a list containing the marks that this student has. And the name is getAllMarks. And we can see in the test that it takes no parameters. Just to make this code compile, I'm going to return null. This is a stub method. The reason I'm writing a stub method is just so I can run this test and see that it fails. So now that I've seen that the test fails, there is something for me to do. So I'm going to start by moving this code from the getTotal method to the getAllMarks method. And then I'm going to return the marks set list here. So I haven't finished writing this code here, but I can run this test now because I have written enough code for this test to pass at least. So we can see that this test passes. And I haven't changed any of the other methods. So now we want to make sure that when I have set a mark, it will appear in this list. So this test can be public void test getAllMarks sumSet, and maybe this test should be none set. In this case, I'm going to set some marks. So I'm going to set a mark in week 1 of 3.5. I'm going to set a mark in week 2 of 4.5. I'm going to set a mark in week 3 of, let's say, 2.0. And then I'm going to assert that when I call the getAllMarks method, I'm going to get this list containing 3.5, 4.5, and 2.0. To do this, I'm going to need a list to compare with. So I'm going to use the arrays helper class to declare a list containing 3.5, 4.5, and 2.0. And then this is the list that I should get when I call marks.getAllMarks. This arrays.asList method is a convenient way for constructing a list just for testing purposes. The list that I construct using the asList method won't behave like a list in the sense that you can append to it or make it longer or shorter, but we can get from it and we can compare it with another list. So therefore it's a suitable method to use in this unit test. And let's run the test to make sure that it fails. So we can see that it does fail. We expected to get a list containing 3.5, 4.5 and 2.0, but actually the list we got was empty. So what I'm going to do is move this code over here into this method so that we can add this code to the getAllMarks method, and therefore the marks from the marks array, if they are set, will go into the marks set list, and therefore they should be returned at the end. So now when I call this getAllMarks SumSet test, I'm expecting this to pass, and it does, because this loop in my implementation class does add the marks to the list. And now I can refactor the getTotal method to use the getAllMarks method to get this list. So all I'm going to do is delete all of this code and call the getAllMarks method to get the marks set list. And I haven't written a test for this because I'm not adding new behavior to the LabMarks class. I'm just changing the way that the LabMarks class implements its existing behavior. So this change that I've just made, I've refactored it to use the getAllMarks method rather than having this loop inside the getTotal method. This should not change the behavior of the getTotal method, therefore I don't have any new tests to test new behavior. What I want to do is run my existing tests to test that the existing behavior is still correct. And since all of these tests pass, I'm confident that I've refactored this correctly so that the behavior of this class is still correct as specified according to the unit tests that I've written. Another refactor I'm going to do is, rather than this complicated code here that gets the starting index for the list, because this list could be longer than 8 and we want just the total of the best 8 marks, the code I've written here is working out where to start adding up in the list. But it would be more convenient if this list would simply contain the best 8 marks already, and then I would just need to get the total of it. Now I don't want to change what my getAllMarks method does, but I'm going to write a getBest8Marks method. And because we're following the TDD methodology, I'm going to start by writing a test for the getBest8Marks method. And to test this method, we want to test that it will return just the best 8 marks. So if I have set more than 8 marks, then it should give me a list of only the best 8 marks. To do this, we're going to have to insert some marks into the list. For this, I'm going to write a for loop. So for the weeks 1 to 12. We're going to insert a mark well, let's say we're going to do the same thing as before. We're going to insert a mark of 1 in the first 8 weeks. And then for the next 4 weeks, which is weeks 9 to 12, we're going to set a mark of 2.0. And then when we get the best 8 marks, we're expecting this to contain 4 1s and 4 2s. So when I write assert equals, I'm going to check against a list of 1s and 2s. So this list contains the 8 marks I'm expecting to get, and then we're going to call the getBest8Marks method to get those best 8 marks. And now I need to write a stub for the getBest8Marks method so that my test compiles. And this method is going to return a list of doubles again. And I'm just going to return null so that I can see that my test fails. And I can see that I do get an assertion error, so this test does fail. We actually got a null, which is because that's what my stub method does. So now we're going to make this test pass by writing the getBest8Marks method. Well, I already have a method that gets all of the marks, so let's call that first. and we're going to return the best 8 marks. But in between, we want to remove the lower marks, and those lower marks are going to appear at the start of the list. So I'm going to just remove the first item from the list repeatedly until the list has a length less than 8. So to do this, I'm going to write a while loop. While the best 8 marks size is over 8, I'm just going to remove the element at index 0, so the first mark from the list. And now let's run my test again. So this test is passing. However, the get best 8 marks method that I've written is not fully correct because this just gets the first 8 marks. So let's write a test that tests for that. And this test is testing that it will still give me the best 8 marks if they're out of order. So I'm going to call my test out of order. And in this case, I'm going to set the first 4 marks are 2, and then the next 8 marks are 1. So let's just change this code. So up to week 4, we're going to get a mark of 2. And then from week 5 onwards, we're going to get a mark of 1. And in this case, I'm going to assert something very similar. I should get exactly the same list. And this list I can expect to be in the same order here as well. Because we're probably going to have to sort this list in order to get the best 8 marks. So let's first run the test and make sure that it fails. So it does fail. I get a list of 8 1s because those are the first 8 marks. And I expected 1s and 2s. Sorry, I get the 1s because those are the last 8 marks rather than the first 8. So that we can see that this test is indeed failing, at least. And this is the list I expect to get because I expect the 2s to be at the end of the list. So it is worth making sure before I move on to my implementation code that this test is failing for the reason I expect it to fail. And when I said I expect to get the first 8 marks, what I really should have expected was to get the last 8 marks because I'm removing from the start of the list rather than the end. So therefore, if I'm getting the last 8 marks, that's going to be just the 1s, which are the last 8 weeks. And that's why I see just the 1s. So therefore, I understand why this test is failing, and I still believe that this is the correct list that I should get. And to solve this problem, all we're going to do is sort the list so that the best marks are at the end of the list. And we're going to use the collections.sort method on the best 8 marks list before we remove the first ones. And then those first ones will be the lowest marks. Now let's run this test to make sure it still passes. And I'm going to run all of my tests to make sure I haven't broken anything else. So all of these tests pass. I've got 12 unit tests and all 12 pass. And now I can use my best 8 marks method to change how this get total works. Instead of getting just the marks set that are all of them, I can just get the best 8 of them. And then I don't need to worry about starting in the correct place. I can just add all of the numbers from the list. I can start at index 0 because I know that this list only has up to the best 8 marks. So this simplifies my getTotal method by splitting its behavior across other methods. Now in total I have more code here, but these methods are shorter and they do a simpler thing. So they're easier to test and they're easier to be confident that I've written them correctly. So let's run this code. Or let's run the tests rather. And because I have made a change to the getTotal method, I've used the getBest8Marks instead of the getAllMarks. I do want to run all of my tests to make sure that they still pass. Again, I'm testing behavior that was already there. I've just changed how it works rather than what it does. And therefore, I don't need to write a new unit test for new behavior. I'm just using the existing tests to test the existing behavior to make sure that still works after my refactor. There's one more change I'm going to make here, which is I don't need to use this kind of for loop here now to get the total of these marks. What I can do instead is use the for each loop because I have a list of marks. These are doubles, and I don't need to use the index to get from this list. I can just get the double from the list directly. So I'm going to say double mark from marks set. and then I'm going to add the mark to the total. And this simplifies my code. And now that I've changed the way the getTotal method works, I'm going to run all of my unit tests again to make sure it still works. Again, I haven't changed the behavior of this class, so I haven't written a new test for new behavior. I'm just running my existing tests to make sure the existing behavior is still correct. So this is as much refactoring of this class as I'm going to do in this video. Hopefully that's given you a good idea of how this unit test class that we write during TDD can be useful even after we've finished writing the class, because as we maintain and refactor the class, these unit tests still become useful. And as I do add new behavior, such as the getAllMarks and the getBest8Marks methods, in that case I do want to add new unit tests. But where I'm just changing how the existing behavior is implemented, as in the getTotal method, I'm just running my existing unit tests to make sure that those methods still work. Let's end the video there.